out of the park and head for first base. You're excited. The score is now tied. Your team has a chance of getting a winning home run. Then you hear a crash. Oh no, the baseball hit a window in a neighboring house. The glass has a big hole in it surrounded by a web of cracks. See the figure below. The glass has changed. It has been broken into jagged pieces, but the glass is still glass. Breaking the window is an example of a physical change in matter. It may also be bad news when the owner of the house finds out. Physical changes in matter. In each of these changes, only the physical properties of matter change. The chemical properties remain the same. It didn't turn into a different type of matter because the type of matter remains the same with physical changes. The changes are often easy to undo. For example, braided hair can be unbraided again. Melted chocolate can be put in a fridge to re-harden. Dissolving salt in water is also a physical change. How do you think you could undo it? Well, all you have to do is evaporate the water and the salt left behind. Here's a picture of cracked glass. It says when glass breaks, its physical properties change. Instead of one solid sheet of glass, it now has holes and cracks. Physical changes in matter. A physical change in matter is a change in one or more of matter's physical properties. Glass breaking is just one example of a physical change. Some other examples are shown in the figure below. In each example, matter may look different after the change occurs, but it's still the same. It is still the same substance with the same chemical properties. For example, smaller pieces of wood have the ability to burn just as larger logs do. This is cutting a log into smaller pieces, changes its size and shape, but it's still wood. Braiding hair changes how the strands are arranged, but not their other properties. Crushing a metal can changes its shape, but the crushed can is still made of metal and has the same properties, such as the ability to conduct heat. Wind-blown sand has worn away this rock to create an arch, but the rock's composition has not changed. The bits of rock worn away by the wind still contain the same minerals as they did when they were part of the large rock. Crisp squares of chocolate melt into a shapeless puddle in the heat. The puddle tastes yummy because it's still chocolate. In each of these changes, only the physical properties of matter change. The chemical properties remain the same. Now we'll talk. There's a video here about physical versus chemical changes, and you can go back to the link and play it if you want. Chemical changes in matter. Did you ever make a volcano like the one in the figure below? It's easy, just mix baking soda with vinegar. What happens when they combine? They produce an eruption of foamy bubbles. This happens because of a chemical change. A chemical change occurs when matter changes into an entirely different substance. The new substance has different properties. When vinegar and baking soda combine, they form carbon dioxide. Carbon dioxide is a gas. It is this gas that causes the bubbles. It's the same gas that gives soft drinks their fizz. This girl is pouring vinegar on baking soda. This causes a bubbling volcano. Not all chemical changes are as dramatic as this volcano. Some are slower and less obvious. The figure below in the video show other examples of chemical changes. Again, go back to the link if you would like to see these chemical changes happen. Here are some examples. Leaves turn color in the fall because of chemical changes in the leaves. When you fry an egg, the heat changes it into different substances with different properties. For example, the clear liquid part turns into a white solid. Some of these copper pennies are bright and shiny. Others are dark and dull. The dull pennies have tarnished. Their copper has combined with oxygen in the air to form a new substance with different properties. The logs in this campfire are slowly burning down to ashes. The ashes are composed of different substances than the logs. They have a different color and texture than wood. These chemical changes all result in the formation of new substances with different chemical properties. Do you think any of these changes could be undone? Nope, not very easily. How can you tell whether a chemical change has occurred? Often there are clues. Several are demonstrated in figures above and above in the window below. So if you want to play this, you can do that at the other link. These chemical changes all result in the formation of new substances. These new substances have different chemical properties. Do you think any of these changes could be undone? No, they cannot. So, signs of chemical change. How can you tell whether a chemical change has occurred? Often there are clues. Several are demonstrated in figures above. To decide whether a chemical change has occurred, look for these signs. Gas bubbles are released. Example, baking soda and vinegar mix and produce bubbles. Something changes color. Example, leaves turn from green to other colors. An odor is produced. Example, logs burn and smell smoky. A solid comes out of a solution. Example, eggs cook and a white solid comes out of the clear liquid part of the egg. Reversing chemical changes. Chemical changes produce new substances. For this reason, they often cannot be undone. Some chemical changes can be reversed, sort of. To do so requires another chemical change to take place. For example, you can undo the tarnish on copper pennies by placing them in vinegar. The acid in the vinegar reacts with the tarnish. This is a chemical change that makes the pennies bright and shiny again. You can try this yourself at home to see how well it works. Other chemical changes cannot be reversed at all or may be very difficult to do. Rusting is a chemical change. If metal rusts, the best you can do is sand off the rust to get down to the shiny metal. Although the metal may now be shiny, the rust was removed. The rust was not changed back into the original metal. Some chemical reactions occur only in one direction. These reactions are called irreversible reactions. For example, you cannot change a fried egg back into a raw egg. Can you think of some other irreversible reactions related to cooking? Would you like a piece of cake? To make a cake, you mix items such as eggs and flour. They're mixed together and baked to form a cake. The cake can't be unbaked and unmixed, so making a cake is an irreversible change. Therefore, baking is a form of chemical change. Temperature affects changes in matter. Have you ever burned something on the stove or in the oven? Do you know why things burn? It all has to do with temperature. Changes in matter are affected by temperature. For example, what if you place a cake in the oven and you leave it in too long? What do you think will happen? That's right, it will probably burn. The same thing will happen if the oven setting is too high and you apply too much heat. In either case, heat has affected the rate of change in matter. It's probably obvious that when the temperature is increased, a chemical change like cooking will occur faster. What about a physical change? Are physical changes affected by temperature? Most of us have seen steam rising off a wet road after a summer rainstorm. This happens because the road surface is very warm. The warm road and air temperatures cause the water to evaporate quickly. The liquid water is turning into water vapor, but it is still water. The evaporation of water is a physical change. So yes, temperature affects the rate that physical change occurs. Are there other examples you can think of? What about how fast something melts? Have you ever left a candy outside in the sun? Just like how temperature increases the rate a substance dissolves, temperature affects the rate of change in many other ways. As temperature increases, changes in matter happen more quickly. For example, do you think an ice cube will melt faster in warm temperatures? Of course they will, which is why we keep ice in the freezer. If not, they would melt and eventually evaporate. When temperatures are lower, change happens more slowly. Think about your refrigerator. What happens if you leave the door open? Items in the refrigerator may thaw, but they also may spoil quickly. We use refrigerators to slow down the natural rate of change in the foods we eat. Food left out can spoil quickly. That's why it's really important to keep foods cool. The next time your mother tells you to close the refrigerator door, don't just do it because she told you so. Do it because you know a lot about physics and the rate of changes in matter. Conservation of mass. This will be new to us. If you build a campfire, you start with a large stack of sticks and logs. As the fire burns, the stack slowly shrinks. By the end of the evening, all that's left is a small pile of ashes. What happened to the matter that you started with? Was it destroyed by the flames? It may seem that way. What do you think happened? The truth is that the same amount of matter will still exist. The wood changed not only to ashes, but also to carbon dioxide, water vapor, and other gases. The gases floated off into the air, leaving behind just the ashes. Although matter was changed, it was not created or destroyed, because the same amount of matter still exists. We can say that matter is conserved. You may wonder how it can be conserved if something is now missing. It's really not, right? So this fire, these logs, put off oxygen and carbon dioxide and water vapor, and then at the end there's ashes. All the atoms are still there. Assume you had measured the mass of the wood before you burned it. Assume you had also trapped the gases released by the burning wood and measured their mass and the mass of the ashes. What would you find? The ashes and gases combined have the same mass as the wood you started with. This example illustrates the law of conservation of mass. The law states that matter cannot be created or destroyed. Even when the matter goes through physical or chemical changes, the total mass of matter always remains the same. This is a lesson summary. Physical changes are changes in the physical properties of matter. They do not affect the makeup of matter. An example of physical change is glass breaking. Chemical changes are changes in the makeup and chemical properties of matter. An example of a chemical change is wood burning. Matter cannot be created or destroyed even when it changes. This is the law of conservation of mass.